Over the past years, the University of Virginia's Sustainability Department has made tremendous efforts towards managing stormwater runoff. Charlottesville receives a yearly average of 48 inches of rainfall, much of which is not absorbed into the ground and thus runs off into nearby streams. Scott Stadium, UVA's football field, is among one of the locations that has trouble draining in a safe and effective way. In addition, large amounts of water are required to irrigate a field of that size. Scott Stadium uses approximately 7 million gallons of water each year. Efforts to collect and use rainwater are needed to reduce the large ecological footprint of Scott Stadium. A cistern is a large vessel that collects, filters, and outputs rainwater for irrigation purposes. Despite the amounts of rainfall that Charlottesville receives, cisterns are installed at only 4 buildings at UVA: Garrett Hall, New Cabell Hall, the Amphitheater, and the Astronomy Building. In hopes to build upon the university's sustainability plan, a cistern should be implemented to mitigate the stormwater runoff at Scott Stadium. The benefits of a cistern at Scott Stadium include reduction in rainwater runoff and flooding, decreased water utility costs, student education, and continuation of UVA's sustainability initiatives. Our proposed cistern would be located along the west wing of the stadium behind Section 110. This area is not currently utilized by the faculty for vendors, bathrooms, or high traffic. The cistern would be constructed above ground and enclosed by a wall. While an above ground cistern may not be inconspicuous, it would avoid excessive excavation and maintain the beautification of the field during the off-season. Additionally, the presence of a cistern would help communicate UVA's efforts towards sustainable practices and education to both students and visitors. The design of the cistern is universally implementable. The stormwater filters through a 4-stage process: a pre-tank filtration, an optional smoothing inlet, a floating filter, and a protected overflow device. The pre-tank filtration spins the rainwater as it enters from the gutter. This functions to oxygenate the water. Afterwards, the water filters through a mesh basket to filter initial debris from the rain. Then, the floating filter skims the surface of the filtered water to obtain the most purified water. The contaminants settle to the bottom of the tank. Finally, a flapping valve on the overflow device allows water to leave the tank in case of an overflow. However, this design does not allow contaminated water to re-enter the tank. This 4-step design is unique because the emphasis is placed upon reducing the amount of contaminants from entering the cistern initially rather than just removing them. Following the implementation of the cistern, more cisterns could be installed at other sports fields and academic buildings at the University of Virginia, in other areas of Charlottesville, and beyond.